Hi, so my name is Matt Hood. Today I will be giving a review on L'Hopital's rule. So earlier in the course we learned about limits, right? Basic, we started from the jump. We were finding out how the function is behaving as it approaches the point or as it reaches the limit of that point. Unfortunately, sometimes when we use direct substitution to plug the x value that it was approaching into the function or into the formula, we would get these indeterminate forms, which there's a few of them. To name some, there's 0 over 0 or infinity over infinity, which is an undefined number. So we said these limits did not exist. In some circumstances, we learned that you could factor out some factors and cancel them out, and then you could find the limit of what was left. Or you could divide by the highest exponent in the denominator, and that would help you to find that limit that way. That being said, sometimes still we could not find the limit. And here is where the L'Hopital rule comes in. And the L'Hopital basically just says if we have an indeterminate form of 0, 0, 0 over 0, or infinity over infinity, or negative infinity over infinity, we can find that limit by simply differentiating the numerator and the denominator until we can directly substitute so that it is not indeterminate any longer. So what that looks like is if you have limit f of x, you have limit f of x over g of x. That will equal the limit of f prime of x over the limit of g prime of x. Like so. Excuse my messy work. Anyway, so the main takeaways of this is that while these limits may or may not exist, we can determine their behavior by applying the L'Hopital's rule as many times as necessary to find the limit. So the limit is, by definition, it's how the function is behaving near that point, right? So it's not on that point, which is what we were looking for if we directly substitute. But this allows us, this differentiating allows us to see how it would behave near that point, right? So sometimes upon first application, the limit will not be clear, and it'll still be indeterminate. So I'll give an example of that here. So if we have limit as x approaches infinity of e to the x over x squared, right? And then we take that, we direct substitute infinity for the x's. So let's call it 1,000, right? So we have, or no, 10,000. We'll go e to the 10,000, right? Oh, that's too much. E to the 1,000. Anyways, that will give you the indeterminate form of infinity over infinity, right? So here we go. We use the L'Hopital rule. So the the derivative of e of x, or e to the x, is e to the x, and the derivative of x squared is 2x. So then we direct substitute again. Unfortunately, we find it is still indeterminate. It's infinity over infinity. You can follow along, right? We'll go again. So we'll do L'Hopital's rule again. The derivative of e to the x is e to the x still, doesn't change. The derivative of 2x is 2. So now our denominator is going to be 2, so we're obviously not going to be in the indeterminate form infinity over infinity anymore. What it's going to end up being is just infinity. So we had to apply L'Hopital's rule 1, 2, twice. And we ended up finding the limit as x approaches infinity is infinity. All right, so another example, I can show you using the indeterminate form 0 over 0. So say we have limit as x approaches 2 of x squared plus x minus 6 over x squared minus 4. So if we plug 2 in for the x's, we'll get 4 plus 2 minus 6 over 4 minus 4. The numerator is 0, the denominator is 0. Indeterminate form. There you go. Lucky you, you get to use L'Hopital's rule. So, derivative of x squared plus x minus 6 is 2x plus 1. Derivative of x squared minus 4 is 2x. We plug it in again. 2x plus 1, you plug in the 2. 4 plus 1. 2x, plug in the 2. 4. So then you have 5 over 4. That is your limit of x squared plus x minus 6 over x squared minus 4 as x approaches 2. You can follow along there. So as far as application in future topics that we discuss, this can come in handy when, say, you're drawing curves, you're drawing graphs, because there will be a discontinuity at these limit where there's an indeterminate form, because obviously there is no value there. That's why you couldn't find it to begin with, but there is still a limit, right? Because say there was a removable, or there was a hole, right? It's still approaching the same number from both sides. So that limit clearly exists. However, that being said, we had to do a little work to find it. Same with when you're drawing a vertical or a horizontal asymptote, you're looking for the limits. So this applies there as well. Yeah, so the L'Hopital's rule is very helpful. You can't give up on a limit when you just see that the value is undefined, because as it might turn out, the limit could exist. And then how would you feel about that if you gave up? Not too hot. All right, good luck. I hope you all do fantastic on the final. Let me know if you have any questions.